All right, in this video, I'm going to focus on compound interest. So interest that's paid on the principal plus any interest that you've earned previously is called compound interest. All right, so after a certain period, the interest that you've earned is going to be added back into the account, and then the principal plus that interest is going to be earning interest during the next time period in which they calculate the interest. So interest can be added back to the account at the end of a year, but sometimes it's added back more frequently than that. Okay, so that time interval is called the compounding period or period. So they might add the interest back semi-annually, quarterly, monthly, or daily. This is going to matter when we work with compound interest. Okay, so we're going to wind up using a formula. This is the one we're going to wind up using, where there's a letter that we don't know about yet. We already know what A, P, R, and T stand for. It's the same as what it stood for with simple interest. But now they're going to be calculating the interest and adding it back into your account before they calculate interest the next time. Okay? So when they do that, we need to know how often they're going to be calculating the interest and putting it back into our account. So semi-annually is going to mean that they're going to do that twice. Quarterly means they're going to do it 4 times. Monthly, they'll do it every month. So N would be 12, and daily, N would be 365. Every day, they're going to calculate the interest. So generally, the more often they calculate the interest, the better, because you're going to be earning interest on that interest. So it's good that they add that back into your account so that you can earn interest on that. All right, so in this formula, the A is still the future value or amount, okay? Just like it was with simple interest, the P is still the principal. Let me go ahead and label those. All right, so the A is still the future value. The P is the present value or the principal. The amount that you borrow or the amount that you deposit. Compound interest is typically for things you deposit. Okay. The N is the number of compounding periods. Oops, I didn't spell that right. Let me try spelling that better. The number of compounding periods. Let me write that more informally. It's the number of times they're going to calculate the interest. Number of times interest is calculated and added to your account in 1 year. So it's the number of compounding periods in a year. And then just the T part, just the T is still time in years. Okay. Notice at the N, the new thing goes in 2 places. See how it's here and also there. Okay. All right, so if we're trying to find the future value of 8,560 at 4% compounded quarterly for 8 years, it's like you're depositing $8,560 in your bank account, 4% annual interest. They're going to calculate the interest 4 times throughout the year and add it back to your account, and then you're going to do that for 8 years. So we're going to be using that formula that you see above it. So A is what we're looking for. The 8560 goes in for the P. The R is 0.04. They're going to calculate, quarterly means N is 4. So we're going to put a 4 there. And then the exponent is going to be 4 times 8. That exponent causes the most problem because of how you type this in. Okay? All right, so when you do that, you really need to work out. Let me move this n equal 4 up a little higher. So quarterly means n equals 4. Okay? So when you type this in, go ahead and just put 32 in as your exponent. Okay. And what you should get if you've typed it in correctly is around $11,000. It's $11,769.49. Generally, you'll be rounding to 2 decimal places anytime that it's any of these problems because it's really money. Okay. Now, that 1 plus 0.04 divided by 4 actually simplifies to 1.01. So sometimes it's easier to go ahead and work that out before you enter it. But you do need to watch out because you do not want to be introducing any round-off error. So if that didn't turn out to be exact, it's usually better to do what I did right over there, where you just type all that in at once. Okay. All right, now, also when I type that in, like I'll show you on my TI-30, I would type in that left parenthesis 1 plus, all of that looks pretty much. That fraction bar, I would just use my division key, and then I would use that little caret key I have raised to the 32 power. And put the 32, don't put 4 times 8. Okay. And then those of you with the multi-view calculator, yours, you can put it so it looks just like what you see above that. So I'm not so worried about you all. All right, let me do one more compound interest problem, but let's do the kind where I'm reversing the process. Now, you'll have a lot more of these in homework where we just kind of change the terms of it. Like instead of quarterly, it might say semi-annually or monthly, right? So you'll practice using that formula. All right, now for the problem number 5, this time we want to know what we have to deposit today so that in the future I'm going to have $18,000. Okay, so when I'm thinking about that, the 5% would be 0.05. That's my R. Okay, my T would be the 20 years. I'm going to leave the money there for 20 years. The N, because it says monthly, the N would be 12. And then the tricky part is the 18,000, that's your A. That's how much you want to have in the future. So this is kind of like the question we did here, number 3. We know our A, we're looking for our P. Okay. All right, so my A, I know, let me just plug in. So my A, I know, is 18,000. So I'm still thinking about that same formula. P, and then I'm going to have 1 plus the R, which is 0.05. I'm going to divide it by 12, and then my exponent's going to be 12n times the T, which is 20. Okay. All right, so here's a case where that 1 plus 0.05 divided by 12 would turn out to be a decimal, 1.004166. It would go on for a while, and you don't want to introduce round-off error. So really the best thing here would be to come in and to realize, since that's multiplication between the P and all of that, that to get P by itself, I could take that 18,000 and just divide it by all of this. And then that 12 times 20, go ahead and work that out. Go ahead and do those two and get that 240. That's how many total compounding periods there are going to be. All right, that you'll enter it, you'll get it entered more correctly if you were to do that. Okay, so try this. Your answer on this one should turn out to be less than the 18,000. Okay, and if you're trying to type it in one step, you're going to need a parenthesis down here where I have the parenthesis. Okay. And you're going to need to type in raised to the 240 power rather than raised to the 12 times 20 to be sure that it's going to do order of operations properly. Those of you with the multi-view can make it look just like that. So that's, you've got a little bit of an advantage. All right, and then rounding off to the 100 spot, you should get $6,635.60. Okay.